Hey Math 21ers, last example in section 3.8. So we're going to find a difference quotient. I want you to take note that the function that we're looking at in example 9 is a quotient. So much like example 6, we're going to be finding a least common denominator. It's super common when you have a fraction for your original function that ultimately when you do your algebra, there's going to be some sort of LCD. So as I start to go through this, I'm not going to do my side hustle of finding f of x plus h and f of x separately. I'm just going to start with my difference quotient, and we're going to go from there. All right, so f of x plus h, let's do this. So this expression should be x plus h plus 2 over x plus h, because if I want f of x plus h, I'm going to put an x plus h in here. So x plus h plus 2 and an x plus h down here, x plus h. All right, I'm going to subtract out my original function of x plus 2 over x, and I'm going to put that in quotient to h. Okay, so my LCD, I'm going to put this off to the side here. My LCD is x times x plus h. So I'm going to clean up, or I'm going to start to clean up that numerator a little bit. So again, I'm going to give myself just a ton of room for algebra. There's always so much algebra. All right, so I'm going to take my x plus h plus 2 over x plus h. I need to multiply that by x over x. I need to subtract out x plus 2 over x. I need to multiply that by x plus h over x plus h. And before I do the next step, I just want to mention, I got to be real careful with this subtraction here, this negative symbol. I got to distribute it to the numerator carefully. All right, so I'm going to go ahead, simplify my numerator. All right, so this is going to be x times x plus h plus 2 over x times x plus h minus, and this is going to be, I'm going to protect both of these binomials with parentheses, x plus h. Right, so now on this numerator, with these two fractions, I have common denominators, so I can combine them into one fraction with this denominator and just subtract the numerators. But again, I'm going to be super careful with that subtraction to distribute that properly. Okay, so my fraction in the numerator has a denominator of x plus h. So this is, let me get a nice long fraction bar. I think this is going to go for a while. X times x plus h plus 2 minus x plus 2 x plus h. All right, so I'm going to even extend this a little bit further. Okay, so what I'm going to do is I'm going to multiply all of these together. So I'm going to distribute the x, and then I'm going to do the foiling first, and then I'm going to subtract. So I'm going to break that up into two steps, just in an effort to be as careful as I possibly can. So x plus h. But let me put a longer fraction bar because I'm pretty sure I'm going to have a lot of terms here. So x times x is x squared plus xh plus 2x, and I'm going to subtract out, let me leave this in parentheses for now. All right, first x times x, x squared, outer x times h, oops, put a little marking there. Okay, so x times h is going to be xh, inner is 2x, and last is 2h. All right, let me move this in just a bit. Okay, now that I've done the multiplication from PEMDAS, now I'm going to go ahead, or I should say I've done this multiplication. I'm going to send the negative through. And then we're going to see what cancels. And I'm going to hope something does cancel, because that's usually a little bit of a green flag. X plus h. All right, here we go. So we have, let me make a longer fraction bar. So x squared plus xh plus 2x, okay, distribute the negative, so minus x squared minus xh minus 2x minus 2h. Okay, so let me go ahead, start to see what cancels. So I heard the x squared and the x squared, that canceled. And then I can kind of see the 2x and the negative 2x. And then there's just a lot of stuff in there, so what I'm going to do, I'm just going to see what I have left for right now. Because sometimes it's hard for me to just kind of keep track of what has and hasn't canceled. So let's see. I have an xh left up here. I have a minus xh. So I'm seeing that actually could cancel. And then I have a minus 2h. All right, so for me personally, I think there were so many x's and h's here, I didn't see the other term that would cancel, so I'm going to go ahead and cancel that. So let me collectively see, we've got negative 2h over x plus h, and then I've got another h here. So dividing by h is like multiplying by 1 over h, so I think one more thing is going to cancel. Negative 2h over x plus h times 1 over h, and then, yep, these are going to cancel, so ultimately this leaves me with negative 2x plus h. All right, so that is my end game answer. That is my difference quotient. So again, just kind of reminding you that when you have, like we saw in examples, I think 5 and 8 with polynomials, we're going to FOIL a bunch of stuff out, cancel. With fractions, there's going to be a least common denominator you've got to find, and then stuff's going to cancel. And we saw in example 7, when you have a radical, you're going to multiply by a conjugate. And those are the 3 most common types of algebraic techniques you'll have to use when you do all of these difference quotients. All right, thanks so much. Bye.